Okay, on to the second page of our review test. Here we've got three functions. They're definitely functions. We just want to sketch and label as much as we can, showing all key parts. Again, I've given you a little bit of a word bank here, but that is not everything. So you got to know what you're doing here. Go back. This is a quadratic. Go back and look at those worksheets. With a quadratic, it's a parabolic shape, and you should be able to get those 5 points. Okay, so look for the 5 points of a parabola. All right. So in this case, the easiest point is going to come is the vertex. Maybe it's not the easiest, but minus b over 2a is going to give me minus a minus 9 all over 2 times 1. Okay, that gives me 9 over 2, which is 4.5. So I go 1, 2, 3, 4, 5, and I'm halfway in between. Don't let the fractions scare you, all right? This is something that everybody has to deal with. Don't write the scale on this yet until you've graphed all of it, because you might want to change some numbers around. In fact, it's not a bad idea to have a rough draft first. But I put in, I do f then of 4.5, and I get 4.5 squared minus 9 times 4.5 minus 10, okay? Well, 4.5 times 4.5, okay, that is going to be 2.25, and then it is going to be 18, so I get 20.25, and that's positive, and then 4.5 times 9 is 40.5, minus 40.5, and then minus 10. So that's going to give me negative 20.25 minus 10 gives me negative 30.25. All right? So I'm going to say that's 10, 20, 30, and there I am at 4.5 negative 30.25. All right? That's not off the page, off the screen. Then, so that's the vertex, okay? Now I do the simpler problem points. I think I just let x equal 0, and I go to negative 10. So there it is, negative 10. If I've gone 4.5 units this way to get to that point, I can go symmetrically 4.5 units to get to that point. It's always twice this amount, and at the same level as this one that I did not write in, 0 and negative 10. That's the symmetric point. Okay, so I'm going to skip over that, but these really should be kind of common sense to you, I think, especially when you're plugging in 0 for x and stuff like that. Now the question is, where are these points right here? Okay, well, to do that, all we need to do is factor. So I've left a little bit of room here. Can you think of two things that multiply to make 10, that subtract to make 9, or two things that multiply to make negative 10 that add up to make negative 9? Really the same question, and that's minus 10 and plus 1. Okay, so by doing that, I can see that, okay, this 0 out here is going to happen when x equals 10. 10, comma 0. This one happens at negative 1, comma 0. All right, so these are my x-intercepts, or my 0, okay, zeros. And there's my symmetric point, and this is my y-intercept. Okay, so those are the 5 points that you want to know and be able to find for a second-degree polynomial or a quadratic function. All right, next one. This is a rational function. Again, it's all about when you get division by 0. Before you tackle it, it's worth looking to see if you can factor anything out. I can definitely take out a 2 from the top, and I get 2 times 5x squared minus 2 over 2 times x squared minus 25. Okay, well, these 2's can cancel, and nothing, no harm comes from it. I can factor this. This is the difference of 2 squares, but I will not be able to cancel anything down here. This factors to be x plus 5 times x minus 5. Okay, and so that gives me my asymptotes. I'm going to maybe just make this be half 2.5 units. So each one of these squares stands for 2. I'll fit this in a little bit more easily. Okay. And then I'm going to try to anticipate what the horizontal asymptote is. Again, after I've canceled 2's here, or actually we don't even really need to worry about that, especially if we use our catchphrase. Do you remember it? Okay. Is it bigger on the bottom? No. Is it bigger on the top? Nope. It is equal. Exponents are the same, okay? So that means divide coefficients. 10 divided by 2. Okay, that equals 5. So I have a horizontal asymptote that it'll be approaching that is f of x equals 5. All right? So what's it going to do? This is going to do those swoopy things in here, and that's where you pop it on your calculator and you see what happens. All right? I'm going to I'm going to anticipate that we can find those very simply if we keep this in factored form, right? And if I think about going to a point that's a little bit to the minus side of -5. If I'm at like -5.1, just ask yourself what's going to happen. -5.1 plus 5, that's going to be a minus sign. -5.1 minus 5, that's going to be minus. This will be very close to 0. So we know that the denominator is going to be very, very close to 0. All right, that's why we've got that dotted line there at our asymptote. If this is negative and that's negative, they're going to multiply to be positive on the denominator. Okay, and then in the numerator, I'm squaring that negative. Okay, that -5. So that's going to be like about 25. That's going to be a big number minus something. So that's going to be plus. So it's going to be a plus over a plus, and it's going to be a big number over a small number. So this is going to be high like this, and then it's going to come swooping down like that. Okay? So in the same way, you can then find out what is going on here without your calculator. All right? I can't pop that into my calculator and film it easily because I don't have my calculator with me, but I'll let you do that. But you're going to take that graph from your calculator, and it might be like a heartbeat thing like this, and you're going to then take your knowledge of where these boundaries are to fill in what it's doing. All right. For instance, if I plug in 0, I get -4 over 50, which is a positive, very, very small number. I know it's going to go approximately through there. Okay. So this one here, all right, is a third-degree polynomial. All right. Again, we're going to try to find if it's possible to break it down because we're interested in the zeros. We're also interested in what's going on in the right-hand and left-hand side. Here the lead coefficient is plus, so I know it's basically going to go like this, up on the right and down on the left. Can I factor this? Okay, I can take an x out of everything, and what I'm left with then is x squared minus 13x plus 30. Okay, whoops, 30. And then I ask, can I factor that? If I'm good at factoring, I'll give it a try. I think it turns out that you can factor it to be x minus 10 and x minus 3. If you're not good at factoring like that, then you can put it into the quadratic formula, and if you go carefully, you'll get your zeros. This has a 0 when x equals 10. This has a 0 when x equals 3. And this has a 0, guess what, when x equals 0. All right? So I know that, and again, I'm going to have these each be 2. There's a 0, there's a 0 at 3, and there's a 0 at 10. So my graph is going to go basically like this. Okay? And I can label these as my roots or my zeros or my intercepts in each case. But that is the basic shape, and that is about all you need to sketch in for that. All right?